Designing a homogenizer stator and rotor involves several factors, including the number of teeth and slot width, to achieve a good shear rate and flow rate. Here are some guidelines to consider. 1. Determine the desired shear rate and flow rate. The first step is to define the required shear rate and flow rate based on your specific application and desired homogenization process. 2. Consider the product characteristics. Understand the viscosity, density, and particle size distribution of the material to be homogenized. These properties will influence the design parameters. 3. Calculate the rotor speed. Determine the desired rotor speed based on the required shear rate and flow rate. The rotor speed should be high enough to achieve the desired homogenization but not too high to cause excessive heat generation or product degradation. 4. Determine the stator and rotor geometry. The number of teeth on the stator and rotor, as well as the slot width, will affect the shear rate and flow rate. The general rule is that higher tooth numbers and narrower slot widths will result in higher shear rates. However, this also increases the risk of clogging and requires higher power consumption. 5. Consider the material of construction. Select materials that are durable, corrosion resistant, and suitable for the specific application. For example, stainless steel is commonly used for homogenizer stators and rotors due to its resistance to chemical reactions and wear. 6. Prototype and testing. Once you have determined the initial design parameters, it is advisable to build a prototype and conduct testing to validate the performance. Adjustments may be necessary based on the results. 7. Optimization. Iterate the design based on the testing results to optimize the shear rate and flow rate according to your specific requirements. This may involve adjusting the tooth number, slot width, or other geometric parameters. Remember, the design of a homogenizer stator and rotor is a complex task that requires expertise.